Welcome to the third part of our video chemical reactions and equations. We are going with the third part in this video. Already we have discussed combination and decomposition reaction. So we discussed the displacement reaction in this in the beginning of this video. So let us start the discussion on the displacement reactions. So these are the reactions in which a more reactive element displaces a less reactive element from its compound. As I already told, this reaction involves a reaction between a compound and an element. The other element is more reactive than one of the element in the compound and it displaces him. We take a very important example of a copper sulfate solution and iron. That's the reaction. The copper sulfate solution is blue in color, and the iron that we take originally is just an iron nail which looks gray in color. This is a copper sulfate solution. This is the iron nail. Iron nail is dipped in copper sulfate solution by using a thread, and this is the test tube. This is the stand. Okay. So this is the arrangement. What happens after we take out the iron nail from the copper sulfate solution? What happens is that the iron taken out from CuSO4 solution looks gray in color. The color has changed from this steel color to this grayish color. So how this has happened? So we take 3 iron nails, we clean them by rubbing with sandpaper. We take 2 test tubes A and B and add 10 ml copper sulfate solution in each test tube. Immerse 2 iron nails in CuSO4 in test tube B. Keep 1 iron nail aside for comparison. So what actually happens in this reaction is copper sulfate is CuSO4 plus Fe is iron. Now iron will make a compound called FeSO4 plus Cu. So that is the reaction. So copper sulfate solution turns into ferrous sulfate solution. Copper sulfate solution color also changes. And Fe is there. So CuSO4 plus Fe gives you FeSO4 plus Cu. That's the reaction that has taken place. Hence, the color has also changed for the iron nail, and the color of copper sulfate solution also changes due to formation of ferrous sulfate solution. See this. And we understand CuSO4 and Fe is kept. Later on in the reaction, copper is formed. So copper deposits get deposited on the iron, and FeSO4 solution is formed wherein the blue color is gone and greenish color has come. So that has happened in this reaction. We see after 20 minutes it is found that the iron nails become brownish in color. The color of iron nails become brownish. Blue color of CuSO4 solution fades and becomes green. So this is due to the displacement of iron by copper from CuSO4 solution. Okay, and this is the reaction FeS plus CuSO4, FeSO4 plus Cu. Students can give this example in the examination. You can give the definition of displacement reaction, and you can give this example as the example of a displacement reaction. So Fe plus CuSO4 gives FeSO4 plus Cu, and the color changes from blue to green, and the nail, iron nail, has a deposit of copper, so its color also changes. Let's hope this is clear. Let's move ahead and see some more examples of displacement reaction. Zinc and metal reacts with CuSO4, copper sulfate solution, blue in color. Zinc reacts with it. Zinc sulfate is formed plus Cu. The color has changed from copper sulfate to zinc sulfate plus Cu. Pb, which is a lead, reacts with CuCl2, copper chloride. We get lead chloride formed plus Cu. Zinc and lead are more reactive elements than copper. They displace copper from its compounds. Okay, I hope this is clear till here. Now we venture into the double displacement reaction. These are the reactions in which there is an exchange of ions between the reactants. As I already told, double displacement reaction are the reactions that involves the reaction between two different compounds. Like we take the example of sodium sulfate plus barium chloride, and what happens here is barium sulfate and sodium chloride salt is formed. See, sodium chloride salt will be formed at the bottom. Sodium sulfate comes as a white precipitate. Okay, barium sulfate, I'm sorry, barium sulfate is formed and it forms a white precipitate, and NaCl is formed at the bottom. Test tube contains solution of barium chloride. and a test tube containing solution of sodium sulfate is added to barium chloride, and this is formed. We get a NaCl at the bottom and BaSO4 barium sulfate white precipitate is formed. So take 3 ml sodium sulfate solution in a test tube. In another test tube, take 3 ml barium chloride solution. Mix the two solutions. White precipitate of BaSO4 is formed by the reaction of SO4 2 negative and Ba2 positive. The other product sodium chloride solute remains in the solution. Any reaction that produces a precipitate, so any reaction that produces a precipitate is called a precipitation reaction. Okay, I hope this is clear. A white precipitate is formed here, so it's a precipitation reaction. Now let us see double displacement reaction, a reaction between a lead nitrate plus potassium iodide to form yellow precipitate of lead iodide. This is again a double displacement reaction. So chemistry is all about memorizing or understanding the definitions, presenting them in the best possible manner, and also remembering some chemical equations to back up with that answer. If we are good at giving definitions, writing good definitions and giving good chemical reactions as example, we are good to go for chemistry. Now we discuss another important topic, the oxidation and reduction. Oxidation is just the gain of oxygen and loss of hydrogen during reaction. The substance is said to be oxidized. Reduction is the loss of oxygen or gain of hydrogen during a reaction. The substance is said to be reduced. Now we take an example of magnesium ribbon in oxygen that is burned. It gives magnesium oxide. Here magnesium is oxidized. Why? Because magnesium has gained oxygen. Okay. Now see this Cu, copper, when heated in oxygen gives CuO, copper oxide. So copper has gone oxidized. Heat a china dish containing about 1 gram copper powder. The surface of copper powder becomes coated with black copper oxide. This is because oxygen is added to copper and copper oxide is formed. Okay. Take another example. If hydrogen gas is passed over the heated CuO, we are passing the hydrogen gas over the CuO. The black coating turns brown as the reverse reaction takes place and copper is obtained. Copper oxide plus hydrogen gives us the reverse reaction of copper plus water. So the loss of oxygen is called reduction. So CuO loses oxygen. So this is reduction. And the hydrogen gains oxygen, so this is oxidation. See, you have to represent it like this, like an arrow, reduction and oxidation. So when one reactant gets oxidized and the other reactant gets reduced in a reaction, it is called oxidation reduction reaction. It's a redox reaction. So redox reaction are those reactions in which both oxidation and reduction reactions are taking place simultaneously at the same time. We take some more examples of redox reactions. Carbon is oxidized to CO and ZNO is reduced to zinc. See, ZNO has reduced to zinc when oxygen is lost, so is reduction. Carbon is oxidized to CO. Carbon monoxide is oxidation. So ZNO plus C is Zn plus CO. Now we get one more equation. HCl is oxidized to Cl2. HCl is oxidized to Cl2 because it has lost the hydrogen, and MnO2 magnesium oxide is reduced to MnCl because it has lost the oxygen. Clear? So this is another example of a redox reaction because oxidation and reduction both are taking place at the same time. Now we come into the topic corrosion. Corrosion is something that everyone is aware of. It is a process by which a metal is attacked by substances such as moisture, acids, etc. Black coating on silver or green coating on copper. These are some of the examples of corrosion. Like in silver, you will see a black coating and a greenish coating on copper. See, this is the green coating on copper. We can see copper coins. We can see copper coins. They have got a greenish coating onto them. This is corrosion. And black coating on silver. These are silver. They have got a black coating into them. This is iron. See the rusting of iron. Iron is rusted. This is natural. It has become like this. So this is all examples of corrosion. Corrosion, what is the damage that corrosion is doing? Corrosion is causing damage to car bodies, to the bridges, to the iron railings, to the ships. etc. That's why corrosion needs to be avoided. So what is the definition of corrosion is a question. How can corrosion be avoided? What damage does it cause? So corrosion is process by which a metal is attacked by substances such as moisture, acid, etc. You can give example of the black coating on silver, green coating on copper, and you can say it causes damage to car bodies, bridges, iron railings, ships, etc. How do we avoid it? There are multiple methods. Most common method is to paint it, painting, and there are other methods as well. You can just say we can paint the metal and we can avoid corrosion. Okay. Now let us see the next topic, rancidity. What is rancidity? See, this is a fresh oil. Rancid oil is like this. Okay. This is the pickle oil and this is chip. So we will discuss one by one. Whenever a fat and oils are oxidized, whenever there are fats and oil that is oxidized, they become rancid, spoiled, and their smell and taste changes. Their smell and taste will change. Oxidation and rancidity can be prevented by, how can it be prevented? By oxidation, and rancidity. The question is, how can we prevent it? We can prevent it by adding antioxidants. Something called as an antioxidants is added. Antioxidants are the substances which will prevent oxidation to foods containing fats and oil. We will add antioxidants. That is one method. Another method is we will keep food in airtight containers so that oxidation does not take place and rancidity can be avoided. Third thing we can do is we will flush the bags of chips with gas such as nitrogen. Okay. We have the chips, we can flush the bags of chips with gas such as nitrogen. That will also avoid any oxidation and that will also avoid the rancidity. So what is rancidity? Rancidity is a process in which fats and oils are oxidized. They become rancid, their smell and taste change. Oxidation rancidity can be prevented by adding antioxidants. Antioxidants are substances which prevent oxidation to foods containing fat and oil, keeping food in airtight containers, flushing bags of chips with gas such as nitrogen. So I hope this topic is also clear and we have winded up the chapter. The chapter is over. We have discussed a lot of things in this chapter. We started the part 1 by discussing what is chemical reaction and how to write a chemical reaction and how do we know a chemical reaction has taken place and how to balance a chemical reaction by heat and trial method. Later in part 2, we discussed what are the different types of chemical reactions. We started with combination reaction, then we studied or discussed about decomposition reaction. In part 3, we started our discussion with displacement reaction, double displacement reaction, the difference between the two, some examples. Then we went into the important topic of oxidation. What is oxidation? Oxidation is the process of gaining oxygen and losing hydrogen. And we then read about reduction. Reduction is the process of gaining hydrogen and losing oxygen. And whenever in a chemical reaction both oxidation and reduction are simultaneously taking place, we say that such reactions are known as redox reactions. So this was the entire discussion about the different type of reactions. In the end, we discussed about corrosion. What is corrosion? What type of corrosions are there? What are the examples of corrosion? Why corrosion is not good? What damages does it cause? And how it can be prevented. Then we ended the chapter by discussing about rancidity. What is rancidity? How rancidity happens? And what is the definition of rancidity? And how can rancidity be avoided by using some different common methods like using antioxidants, by keeping food in airtight containers, or by flushing the bags of chips with gas such as nitrogen. So we are winding up this chapter. So I hope the students understood this chapter. They found my all 3-part videos useful. They were able to understand the entire chapter. Typically 5 to 6 marks come from this chapter in board exams. This chapter is good to go if you are thorough with all the definitions, with all the concepts, and if you are good to go in this chapter, if you are like thorough with the chemical reactions associated with each chemical reaction. So you should know the definition and also the some examples of the reactions. So I hope this chapter is completely clear. Thank you. Thanks a lot.